Hello and welcome to today's lecture on secured communication. Nowadays, computer network or internet is used for many sensitive applications such as shopping, banking, reservation of railway and airline tickets, in general for e-commerce. And as a consequence, communication of data securely over the network is looming large on the horizon as a massive problem. And in this lecture, I shall try to discuss how secured communication can be achieved. Obviously, the subject is very vast and usually a full course can be offered on secured communication. But I shall try to give an overview of various aspects of secured communication in 2 lectures. Here is the outline of today's talk. I shall give a brief introduction where I shall explain the need for secured communication and what is really meant by secured communication. As we shall see, cryptography will play a very important role in secured communication. In fact, cryptography can be considered as the panacea to this problem. And we shall see there are several cryptographic approaches. Basically, it can be divided into 2 broad categories. One is known as symmetric key cryptography, where there are several variations like traditional ciphers using monoalphabetic substitution, polyalphabetic substitution and transpositional cipher. Then there are block ciphers where different transformations are used. We shall explain what are the different transformation and explain one important cryptography technique which is known as data encryption standard DES, which is widely used. Then another new cryptography technique which is known as public key cryptography, I shall discuss about it, and one application of public key cryptography, that is the RSA algorithm, will be discussed. And on completion, the student will be able to state the need for secured communication. They will be able to explain the requirement for secured communication, and they will be able to explain various cryptographic algorithms such as private key and public key cryptography. Now, let us focus on why secured communication. Why do you need secured communication for applications like e-commerce? The basic objective is to communicate securely over insecure medium. Essentially, what we are trying to do is to communicate privately over public network. So, whenever we use public network and we encounter what is known as insecure medium. What do you really mean by insecure medium? As the message is communicated through these links or communication media, eavesdroppers can listen in and try to tamper it. So, there are some people who can try to get hold of the message or use them for their own benefit or tamper them. Moreover, as we have seen in public communication network, the information has to be stored in switches and routers before forwarding to the next node. And in such cases, information needs to be stored and then forwarded through packet switches. These switches can be programmed to listen to and modify data in transit. So, these are the 2 problems that we encounter while communicating through public media. So, we have to find out the solution, and the solution is we have to develop techniques so that we can communicate securely over insecure medium. And it involves 4 different aspects or 4 different components. First one is privacy. A sender should be able to send a message to the receiver privately. What do you really mean by privately? By that we mean, if the message is obviously this message will be exposed to other people, but he will not be able to understand it. So, it should be unintelligible to others, but it should be intelligible only to the person to which it is being sent. Second is authentication. After the message is received by the receiver, he should be sure that the message has been sent by nobody else but by the sender. So, by authentication we mean that message is coming from the intended sender, not from somebody else we do not know. So, this is known as authentication. So, the security service has to provide this privacy and authentication. And then third parameter or third component is integrity. The receiver should be sure that the message has not been tampered on transit. So, by looking at the received message, the receiver should be able to be sure that the message has not been modified or tampered on transit. Finally, the fourth important component is non-repudiation. The receiver should be able to prove that the message was indeed received from the correct receiver. That means, suppose a subscriber tells a bank to pay some money to a particular customer. Now, over phone or over electronic media, but after some time he may come to the bank and say, no, I did not send it. Then it is the responsibility of the bank to prove that that person actually gave the instruction to pay. So, that is the function of the non-repudiation. So, these are the services to be provided by the secured communication network. And as we shall see, possible solution is to use cryptography. To achieve all these services, we have to use cryptography. So, in this lecture I shall try to give an overview of the cryptographic techniques, various techniques used in cryptography. First, let us have a look at the cryptography model. In cryptography, we require 3 characters. Actually, to tell the story of cryptography, we require 3 characters. One is the sender, another is the receiver, so here is the receiver, and in between there may be an intruder. And so, sender, receiver and intruder is in between the sender and receiver. Usually we give 3 names. If you look at some textbook, you will find Alice, Bob and Eve, or this kind of names from Europe is taken, but I shall borrow the characters from Ramayana. The sender we shall consider as Sita, the receiver is Ram. On the other hand, the intruder we shall consider as Ravana. So, we shall use 3 characters Sita, Ram and Ravana to tell the story of cryptography. Now, a message is being sent is sent by the sender Sita, and that is known as plain text. Usually that message is known as plain text, and that is being encrypted, and for encryption purpose a key is being used which is secret, which is not known to the Ravana or the intruder or the impostor which is in between. Then with the help of that key, encryption is being performed, and to do the encryption we have different algorithms, and actually the encryption can be done either by hardware or by software or a combination of both. And after doing the encryption, we can say that, say suppose this is the message, and encryption is done by Sita, or you can say this is the key. We can say that the key that is being used is it generates a message, modified message C is equal to encrypted by a key and this is the say plain text P. So, a plain text P, which is the message, is being encrypted to produce a modified message which is known as cipher text. So, cipher text is being transmitted through the media which reaches the other end, and at the other end the receiver or Ramo performs the decryption with the help of the same key or a different key. So, another key is being used for decryption. So, decryption is being performed on C to get back P. So, C is decrypted to get key P. So, this is how the cryptography works. So, a plain text generated by the sender or Sita is encrypted with the help of a key, and that after encryption the message is known as cipher text, that is communicated through the insecure medium which reaches the other end and which is decrypted with the help of another key and to get the plain text. This is the model for cryptography. Now, let us see what are the various alternatives. There are two basic approaches. One is known as symmetric key cryptography, another is public key cryptography. So, there are two basic approaches, we shall consider one after the other in detail. In case of symmetric key cryptography, a single key which is known as shared key is being used by both the parties, that means both Sita and Ram, which are at the two ends, they use the same key, secret key, let it be K, SR, are being used by both Sita and Ram, and this particular key is known only to Ram and Sita, not by anybody else. And and after doing the encryption by using this key KSR, this is being transmitted through the medium in the form of cipher text, and as it reaches the other end, the same key is being used for decryption to generate the plain text by Rama. So, this is how the symmetric key cryptography works, and as I have told, it uses the same key in both directions. Now, this is commonly used for long messages. When you have to use a long message, say some text of few pages or something like that, we can use this symmetric key cryptography. It has got several problems. First of all, it will require a large number of unique keys. For example, if you have got two users, you will require one key. So, if you have 5 users, how many keys will be required? 5 into 4 by 2. So, you will require 10 keys, and in general if you have got n users, you will require n into n minus 1 by 2 keys. That means, if you have got say 1 million user, then you will require 500 billion keys. So, that is the problem of this symmetric key cryptography. The total number of keys is very large, particularly when the number of users increases, the number of keys increases, and this is known as n square problem. Moreover, another problem is distribution of the keys. You have to distribute so many keys secretly to all the users. That means, this key KSR should be known only to Sita and Ram, but nobody else. So, n square keys n into n minus 1 by 2 actually are to be known only to a pair of users, not by each will be known to a pair of users. So, this makes distribution of keys very difficult. Moreover, each user has to store the key in the storage medium. For example, when you have got 1 million users, so you will require about 1 million storage space for each user to store the keys, 1 million minus 1 actually. So, 1 million minus 1 keys ought to be stored by each user to store the keys if he wants to communicate with all the people. So, these are the problems we have to tackle, and how it can be done we shall discuss in the next lecture. First I shall discuss the traditional ciphers where commonly where the characters are used as the unit for encryption and decryption. So, as you know, an ASCII character can be represented by 7 bit, and of course, if you use 1 bit parity, so that makes it 8 bit. So, each character is of 8 bit, and traditional ciphers makes use of performs the encryption character by character. So, the unit of encryption and decryption is in terms of characters. The first one is monoalphabetic substitution. Here the relationship between a character in the plain text and a character in the cipher text is always 1 to 1. So, that means for each character there is a unique character in the cipher text. For example, here the key is used being key that has been used is 3, key is equal to 3. By that we mean the in place of A we shall use a character which is 3 characters away from A, that is D, and this was used by Julius Caesar. That is why it is known as Caesar cipher. So, Julius Caesar was not only a good soldier, good fighter, but he developed the cryptographic technique for secret communication. This is a technique that was being used. So, if we are sending say A in place of A, D will be used in place of B, U will be used in place of C, F will be used, and so on. So, in this way when you use key it has to be done in this manner. Usually the characters can be represented by numbers. For example, A can be represented by 0, B can be represented by 1, C can be represented by 2, and so on. Now, if you add 3 to it to the number, that means say 0 plus 3 will make it 3. So, in place of 3 we shall be using D in place of A. Similarly, when we do the decryption, then you have to subtract 3. So, we find that in case of this monoalphabetic substitution, the encryption and decryption operation are just the opposite. If we use addition for encryption, we shall use subtraction for decryption. If we use multiplication for encryption, we shall use division for decryption. So, for encryption plus 3 is added to generate the cipher text, and minus 3 is added with the cipher text to get the plain text. So, this is how encryption and decryption is done. Obviously, this is a very simple technique, but the code can be attacked very easily, because you know that from the linguistic point of view, if the each and every character appears with certain frequencies. So, frequency of appearance varies from character to character. For example, characters like E, T, O and A appear more frequently than other characters. So, based on that it can be easily found out. So, that is why it is not very popular. And another approach that can be used, which is known as polyalphabetic substitution, and in this particular case the relationship between a character in the plain text and a character in the cipher text is always 1 to many, not 1 to 1. For example, in Vigenère's cipher, this polyalphabetic substitution is used. So, as you can see here, you can use a matrix, and this matrix provides you information for performing the encryption. So, the character A is replaced by W if it appears in the first row, character B is replaced by R if it appears in the first row. On the other hand, if A appears in the second row, it is replaced by H, or if it appears in the third row, it is replaced by P, or it can be represented mathematically. Suppose you perform mod operation on the number. So, if the suppose and mod you perform mod 10, let us assume, then the first character say A is 0 mod 0 is 0. So, in the first row the characters are I mean all the characters remain as it is. In the second row it is mod 10 of 1. So, it is 1. So, A is replaced by B, B is replaced by C, C is replaced by D and so on. So, in this way up to 10 rows it goes, that means in the 10 row it will be added with mod 9, it will be added with 9. And finally, when it is say row 11, then it will be again added with 1 and then it will be substituted. So, in this way you can perform polyalphabetic substitution, that means the each character is represented by different characters based on the appearance in different rows. Obviously, it is more complex than the Caesar cipher and the code is harder to attack successfully. So, this is a better this gives you better security compared to Caesar cipher. Another approach that can be used is known as transpositional cipher. So, in this case the characters remain unchanged, but change their position to create the ciphertext. In the previous case we have seen that if the text was, let us assume Sita, that SITA, they are replaced by some other characters in the this either in polyalphabetic or monoalphabetic substitution. On the other hand, in case of this transpositional cipher, the same characters are used, however, their positions are changed. How? This is explained here. For example, here this is the plain text, this is the plain text P, and this has to be encrypted, and the key is represented by this box which performs the transposition. So, you can see here if the character in position in column 1 is now placed in position 3 in the ciphertext, the character in position 2 is placed in position 6 in ciphertext and so on. So, this particular diagram represents the 1 is position 3, 2 to 6, 3 to 4 and so on. So, this message, this plain text, they alone live, who live for others gets transformed into this ETEH, NEAOI, L and so on. So, as you can see here THEY, they are present here, but their position has changed. So, you are doing encryption by using this by changing the position, and by you can do the decryption by repositioning in the opposite manner, and you will get back this plain text. So, here you get the ciphertext from this plain text by using this transpositional cipher, and you can get back the ciphertext. So, you can see it is not very secure. The attacker can find the plain text by trial and error based on frequency of occurrence of characters. So, the positions can be altered and by trial and error, and it can be deciphered. That is why it is not very popular. Now, we shall focus on block ciphers. So far we have seen in traditional ciphers where characters were used as the unit for encryption or decryption. Instead of that, in block ciphers what we shall do, a block of bits as the unit of encryption is being used. See, the block of bits can be say 64 bit, or it can be 120 bit, 8 bit, or it can be 256 bit. That can be different for different encryption technique, but usually it is in terms of blocks of bits. So, to encrypt a 64 bit block, one has to take each of the 2 to the power 64 input values and map it onto 2 to the power 64 output values. So, here the mapping should be 1 to 1 as it is shown here. So, this is the plain text P, and which is encrypted by this key to get this ciphertext C. Now, you may be asking what is really meant by a key? What is a key? Key is essentially a number which is secret, which is secret, and it is known only to the sender and receiver, or Ram and Sita, in case of this semantic tree encryptography. So, by using this secret number, encryption is done to generate this ciphertext, and the ciphertext can be decrypted with the using the same key to get back the original plain text. So, in this this mapping from here to here has to be 1 to 1, and this mapping can be done by using two transformations. One is known as permutation, which can be performed with the help of either by hardware or software, and which is represented by P box. As you can see here, this is the input, 8-bit input, and this 8-bit input, their positions are permuted to generate a different number. So, 10101101 gets transformed into 10001111 in the ciphertext when it passes through the permutation box. And to represent this permutation operation, you require k log 2 k bits. For if you have got k bits, and for each position you will require log 2 k bits to represent the position. So, you require total number of k log 2 bits to represent different this permutation operation. On the other hand, another transformation can be done, which is known as substitution, which can be done with the help of S box. S box is shown here, this is the S box. So, here what is being done, first with the help of a decoder, it is converted into another number. For example, here you have got 3-bit input. That 3-bit input is applied to a 3 to 8 decoder to get this it has got 8 outputs. So, and then this output is applied to a P box, and this P box does the permutation, and then it is applied to a 8 to 3 encoder, which performs the reverse operation. So, to get back 3 bits. So, here you have got 8-bit input and 3-bit output. So, here obviously the number is completely different, and the substitution operations require k into 2 to the power k bits to represent the substitution operation of on k bits. So, by using these two transformations, you can do encryption, and I shall explain how you can implement an encryptography technique with the help of this permutation and substitution. So, here we see how it has been done for a 16-bit 64-bit input. First, it has been divided into 8-bit pieces. So, in step 1, the number is divided into 8-bit pieces. So, 64-bit, you have got 8 8-bit pieces. Now, substitute each 8-bit based on the functions derived from the key. So, here you perform substitution based on a key, and the substitution is performed, and obviously here you get different 8-bit number for each of these 8 bits. Then after this is being done, it is you get 64-bit intermediate data. These are these 8-bit 8-bit numbers are recombined to get 64-bit intermediate data, and this is being permuted with the help based on another key. So, permutation is performed again with the help of a key to get 64-bit output. Now, you can perform several rounds of looping to improve the encryption technique, to increase the security of encryption. So, obviously the question arises, how many rounds you will do, and it has been found that as the number of rounds increases, the effectiveness of encryption increases. However, it should not be too large. So, you have to find out an optimal number of looping to do the encryption. Let us see a standard technique that is being used, which is known as data encryption standard, or DES. This was developed by IBM, and subsequently it was adopted by the US government for use in non-classified data, encryption of non-classified data. So, here how it works is explained with the help of this diagram. This is again a monoalphabetic substitution cipher using 64-bit character. So, input is a 64-bit character, this is the plain text, and first step is permutation. As you can see, initial permutation is performed on this 64-bit input. Then it is passed through, this is here it is explained how it is being done. It has got 16 rounds, mean the and the 16 rounds are performed in this way, 16 iterations are performed, and although it has got 56-bit key, 56-bit key, actually a subset of the bits is used as key 1, key 2 and key 16 to generate keys in different iterations. So, with the help of a key processor, this K1 to K16s are generated as the information passes through each iteration, and in each iteration the operation performed is explained here. Here the 64-bit is divided into two parts, say this is your left part and this is your right part. So, right part is swapped to the left part, and then left part, as you can see, the right part is encrypted with the help of that 48-bit key, and so it is this output is function of this right 32-bit and the key, and this is being exclusive ORed with the left 32-bit to get the right 32-bit. So, we get right 32-bit and left 32-bit, and this goes to the next iteration process, and again the same operation is done, but with a different key. So, in this way 16 such, after passing through 16 such iterations, they are swapped, 32-bit 32-bit, these are swapped, and inverse permutation, which is opposite of this initial permutation, is performed. So, altogether as you can see, it has got 19 distinct stages, starting with this initial permutation, 16 different iterations, and then swap and then inverse permutation. So, altogether 19 distinct stages are there to generate the cipher text, and these are the typical features of this data encryption standard. Although the input for data encryption standard is 64-bit long, the actual key used by DES is only 56-bit. Actually it has got the other bits are parity bits. So, parity bits are essentially used for error checking, they do not take part in generating the keys. The decryption can be done with the same password, and the stages must then be carried out in reverse order. So, to perform the decryption operation, you have to just do the reverse operation. So, here that inverse permutation has to be done, then swapping, then it will pass through the reverse process by using the same set of keys to get back the plain text. And as I have told, DES has 16 rounds, meaning the main algorithm is repeated 16 times to produce the cipher text. As the number of rounds increases, the security of the algorithm increases exponentially. As I have mentioned, as you increase the round, more and more security increases, but there is some optimal number, and in case of DES the optimal number selected was 16. And as you have seen, once the key scheduling and plain text preparation have been completed, the actual encryption and decryption is performed by the main DES algorithm, as I have already explained. Now, although DES works for only 64-bit blocks of data, there is need for encrypting large messages. How it can be done, or sometimes small messages, and how it can be done by using DES, and that can be done by using DES, by using different modes of operation of DES. First one is known as electronic codebook, ECB. Second one is known as cipher block chaining, CBC. third one is known as cipher feedback mode CFB, and fourth one is output feedback mode OFB. Let me discuss these four different modes of operation of DES. First one is known as electronic code book ECB, and this is the regular DES algorithm. Data is divided into 64-bit blocks. Since your message is long, it is being divided into 64-bit blocks, and each block is encrypted one at a time, and separate encryptions with different blocks are totally independent of each other, as it is shown in this diagram. So, each plain text is 64-bit, which generates a cipher text which is also 64-bit. So, here you perform some kind of monoalphabetic substitution. A 64-bit number is encrypted to get another 64-bit number, and as you can see, for P1 we get C1, for P2 we get C2, and for Pn we get C1. So, here you have got n 64-bit inputs and we get n 64-bit outputs, which is the cipher text block. Here, as you can see, if Pi is same as Pj, then Ci will be same as Cj, and this is the drawback of this approach. For example, this may give a clue to the intruder or the Ravana. For example, there are 10 persons who are getting the same salary. So, the intruder can find out those 10 persons by looking at the cipher text, because the cipher text also will be the same for those 10 persons, the salary part will be same. In other words, it can provide some message, it can provide some information to the eavesdropper or intruder. So, the message contains two identical blocks of 64-bit, the cipher text corresponding to these blocks also will be identical, as I explained. So, this is not a very good approach. Another problem is someone can modify or rearrange blocks of his blocks to his own advantage. For example, here these two in the cipher text, since they are independent, C2 and C3 can be interchanged, or C4 and C5 can be interchanged, and at the other end the RAM will not know, the receiver will not know that this has been done, but this can be used for different purposes, such as, say, suppose if somebody wants to increase his salary. So, maybe it was 16,000, he can make it 61,000. So, this kind of thing can be done, and as a result this ECB or electronic code book method is not very safe, and as a consequence, because of these flaws, ECB is rarely used. So, to overcome this problem, the second approach can be used, which is known as cipher block chaining, CBC. So, in this mode of operation, each block of ECB is encrypted, cipher text is XORed with the next plain text block to be encrypted. For example, here initially a vector, a random number is chosen, which is known as initialization vector or IV. So, that IV is generated randomly, a 64-bit number is generated, and that is XORed with P1, and then that number is encrypted to get C1. Then C1 is XORed with P2 to get a number which is encrypted to get C2. So, as you can see here, depending on the initialization vector, C1 will be different for different cases. So, and also the P2 is that C1 is exclusive of with P2 and then encrypted by using the data encryption standard. So, by using DES the encryption is being done, and C2 is used to perform exclusive OR with P3 and so on. So, Pn is encrypted with Cn minus 1 and then exclusive OR to do the encryption to generate Cn. So, in this case, suppose if the same P1, Pi and Pj are same, Ci and Cj will not be same, they will be different. And as a consequence, the problem that we encountered in the previous case, that ECB electronic code book does not appear in case of this cipher block chaining method. So, here this makes all the blocks dependent on the previous blocks, and for only thing extra that has to be done is that initialization vector has to be sent along with data. That means, apart from sending the ciphertext C1, C2 and Cn, you have to send the IV initialization vector to the receiving end, so that the decryption can be done by using the same initialization vector, which is a random number, and for in different situations it is generated, new number is generated for different cases. Now, there are situations in which the size of the plain text is smaller than 64 bit. In the previous two cases we have seen we cannot do encryption unless each of these plain text block is of 64 bit. Now, suppose in an interactive from an interactive terminal, data is coming out at the rate of 1 character or 8 bit. In such a case, how do you use DES? That can be done by using this cipher feedback mode or CFB. So, it can receive and send 8 bits, say k is equal to 8 at a time in a streamed manner. So, 8 by 8 it can be generated. How it works? So, it again in this case also use a initialization vector. That initialization vector is loaded in a 64 bit shift register, and that is being used initially to do the encryption by using DES, and the after encryption, that ciphertext that we get, only the leftmost byte is used to perform exclusive OR with the character or at that moment. So, here you see that is being exclusive OR to get the ciphertext. So, in this way character by character it is being done, and then this number is loaded in the shift register. So, you can see here after 10 such characters have been encrypted, this is the snapshot. So, C3, C4, C5, C6, C7, C8, C9, 10 and C10 are already there, and this 16 bit number is used as for encryption with the key, and this is being encrypted, and that resultant number, the leftmost 8 byte of the resultant number is used to get the ciphertext by using exclusive OR with the plain text. So, this is how it is being done. On the other hand, at the receiving end, this is the receiving end. In the receiving end, the exclusive OR is being performed to get the ciphertext, and of course, as long as this number and this number is same, you will get back the plain text P11. So, this is also a snapshot after decrypting 10 characters. So, in the 11 character, when the 11th character is getting decrypted, this is the situation. So, in a streamed manner, character by character encryption can be done again by using DES. Now, let us consider the output feedback mode. This is also a stream cipher, and encryption is performed by XORing the message with the one time pad. Here the entire process is somewhat similar to the previous case. However, here as you can see the that after encrypting, the leftmost 8 bit is exclusive OR with the plain text to get the ciphertext, and instead of the ciphertext, the output of this encrypted data 8 bit data is applied to the shift register. As a consequence, it is not dependent on the plain text. That means, this pad can be generated, this one time pad can be generated beforehand, and then exclusive OR can be performed as the bits are received bit by bit to generate the data. So, bit by bit exclusive OR operation can be done with the plain text. So, in this particular case, if some bits of the ciphertext get garbled, only those bits of the plain text get garbled, because it is here the bit by bit operation is being performed. And in this case another advantage is the message can be of arbitrary length. It need not be even multiple of 8 bit, it can be 6 bit, 7 bit, 2 bit or any number, because here we are performing bit by bit operation. And at the receiving end also the one time pad can be generated, then exclusive OR operation can be performed with the cipher text to get back the plain text. However, this is a less secure method than the other modes of operation that we have discussed. As a consequence, this output feedback mode is rarely used unless it is absolutely necessary. One limitation of this data encryption standard is the small size of the key. We have seen the key size is only 56 bit, and as a consequence it is not very secure. That was the limitation pointed out by the critics of data encryption standard. So, what was done to improve the effectiveness of this encryption? The key length was increased, not directly increasing the key length or changing the size of the plain text. What was done, triple DS or which is known as 3DS technique was developed. What is being done here, each block of plain text is subjected to encryption followed by decryption followed by encryption by using two keys, the K1, K2 and again K1. So, this effectively increases the size of the key. You can say that 56 into 3 is the size of the key, although you are not changing the basic algorithm that is being used by data encryption standard. So, you are performing the standard DES algorithm which operates on 64 bit plain text and the keys are of 56 bit, but you do it in a chain one after the other, that means encryption, decryption, encryption to generate the cipher text, 64 bit cipher text. And this then again decryption can be done in the reverse order, decryption, encryption, decryption to get back the plain text. So, this particular approach gives you much better security. There is no known method for breaking this code. And you can use CBC that we have already discussed, that CBC cipher CBC, that cipher block chaining whenever the size of the data is long. So, CBC is used to turn the block encryption scheme into stream encryption scheme when you have got messages of multiple of 64 bits. So, we have discussed the symmetric key encryption technique of cryptography technique, where we have seen for each user, for a pair of user you require a single key and we have large number of users. To overcome this problem, a more recent method is known as public key cryptography. In this particular case, two keys are used for encryption and decryption. The two keys are known as public key and private key. Here for example, Sita is trying to send a plain text. So, she does encryption with the help of the public key of RAM. This is the receiver RAM. So, by using the public key of RAM, encryption is being performed to generate the cipher text, then it is sent over the medium to the other end and RAM receives it and does the decryption by using the private key. As you can see in this particular case, this public key is for the rest of the world and private key is the secret key that is being used by the receiver. So, here we can see the pair of keys is used with any other entity. So, that means instead of Sita, if somebody else say wants to send another message, they can use the same public key to perform encryption and send it to RAM. As long as the private key is not disclosed and it is known to RAM, RAM can decrypt the entity or message sent by any other person apart from Sita when it is encrypted by the public key of RAM. So, in this particular case the number of keys required is very small. Suppose you have got n users. So, when you have got n users, you require only 2n keys. So, if you have got 1 million users, you will require 2 million keys in case of this public key cryptography. The main difference, as you can notice here, instead of using the same key for encryption and decryption, you are using two different keys. One is public key and another is private key for encryption and decryption. That is the basic approach, basic difference between the public key cryptography and symmetric key cryptography. Now, question arises, what is the disadvantage or advantage of this technique? Advantage, as you have noticed, the number of keys required is small and it is not efficient for, the main disadvantage is that it is not efficient for long messages, because the encryption technique is quite complicated. So, and however, another problem that is present here is association between an entity and its public key has to be verified. That means, this public key is received maybe through network. So, the public key, whether it is coming from RAM or somebody else, an imposter, that has to be verified, otherwise this will fail. That means, in this particular case this verification of this public key has to be performed before using it for encryption. One popular approach for public key cryptography is RSA technique. It was invented by Rivest, Samir and Alderman, and this public key algorithm that perform encryption as well as decryption based on number theory. This RSA algorithm is based on number theory and it can perform variable length, variable key length, long for enhanced security and short for efficiency. That means, the size of the key is not fixed here, it can be long or small depending on the security level that you want or the size of the message. And typically the size of the key is 512 bytes and variable block size can be used. However, it has to be smaller than the key length. So, if it is 512 bytes, the key length has to be smaller than that. So, the private key is a pair of numbers D and N, and the public key is also a pair of numbers E and N. So, using this D and N, encryption is done and decryption can be done by using E and N. So, here what is being performed? It chooses two large primes P and Q, typically around 256 bits, then compute n is equal to P into K Q and Z is equal to P minus 1 into Q minus 1. And it, in the third step is choose a number D which is relatively prime to Z, which is P minus 1 into Q minus 1. Find E, another number such that E into D mod P minus 1 into Q minus 1 is 1. Then for encryption you should use C is equal to P to the power E mod N, and for decryption one can use P is equal to C to the power D mod N. So, this is illustrated with an example. As you can see, 5 and 199 is the public key that is being used for encryption. So, the message or plain text sent by Sita is 6. So, 6 to the power E is 5 here, mod 119 is 41, that is the ciphertext C, and C is sent to the RAM and the decryption is performed by using C to the power D. So, 41 to the power 77, because here the D is 77 mod 109 and to get back the plain text 6. This is the message received by some. So, this is how encryption and decryption can be done, and here you can see the advantage is the keys can be generated, both the that D and E and D, N, E, N, these are all known, but in spite of that it cannot be broken by the Ravanas. Now it is time to give you the review questions. First question is, what do you mean by encryption and decryption? Second question is, what are the two approaches of encryption decryption technique? Third question is, for n number of users, how many keys are needed if we use private and public key cryptography schemes? Fourth question is, how triple DES enhances performance compared to the original DES? Fifth question is, explain how RSA works. And here are the answers to the questions of lecture number 38. First question was, why compressed video is more sensitive to error than uncompressed video? The main reason is, if error occurs in compressed video, the recovered video is more distorted because each error bit affects larger number of bits compared to the uncompressed video. That means, if a smaller number of bits affects larger number of bits after recovering data, that is why it is more sensitive. Second question was, why a media server is used for streamed audio video service? We have seen that the streamed audio video service cannot be obtained directly from the web servers, which uses TCP, and TCP cannot be used because of the error control technique that is used in TCP, which is unsuitable for downloading audio video files. So, use of media server avoids the use of TCP. However, the media player uses the URL in the meta file to access the media server to download the UDP. So, UDP does not use the error control and other thing. As a consequence, it is very suitable for streamed audio video service. So, that is why a media server is needed, and which does not use TCP, instead of that it uses UDP. Third question was, distinguish between streaming of stored audio video with that of live audio video. We have seen that although both the services are sensitive to delay and neither can accept retransmissions, there are differences between the two. First, in the first application, the communication is unicast and on demand. So, that means, whenever we are streaming of stored audio and video, usually it is unicast. It is a person is requesting for some service, and as a consequence it is unicast and usually on demand. On the other hand, when we are performing live audio video transmission, streaming of live audio video, it is multicast in nature and it is live in the second application. So, these are the key differences between two, although both are sensitive to delay. Fourth question was, why TCP is unsuitable for interactive traffic? Answer is, TCP is unsuitable for interactive traffic because of several reasons, such as it has no provision for time stamping and it does not support multicasting. So, these are the limitations of TCP. On the other hand, for interactive traffic, these are the two services needed, and moreover, interactive traffic cannot allow retransmission of packets, which is used in TCP in case of error. As we know, whenever error occurs, it does retransmission by, and that cannot be done in case of interactive traffic. That is why TCP is unsuitable for interactive traffic. The last question was, what are the key features of SIP protocol, SIP protocol? SIP is an application layer protocol that establishes, manages and terminates a media session. It can be used to create two-party, multi-party and multicast sessions. It is independent of the underlying transport layer protocol. It can be either UDP or DCP. So, in this lecture we have discussed the cryptographic techniques, and in the next lecture we shall discuss how these techniques can be used to provide the 4 services I have mentioned. Thank you.